In this video, I'm going to explain clamper circuits simulation using multisim tool. So aim of the experiment is to design and test positive and negative clampers without a reference. So let me explain the theory part. What is a clamper and what is actually difference between clampers and clippers? So as we saw in the previous program, okay, we did a clipper circuit where we clipped some part of the input. So if we give some sinusoidal input, we clipped a positive peak first, next we clipped negative peak, after that we did double-ended also. So in the clipper, the name itself indicates that some part of the output is actually, some part of the input waveform is actually clipped off in the output waveform. But in the clamper, so no part of the input is actually going to remove. Just we are going to add some DC level, we are going to shift the entire waveform into some DC level. So clamper means no clipping, only it will add some DC level. Okay, that's what it's called as DC level shifter. It will add it will add input AC with a DC level. Okay, so two types of clampers are there: positive clamp and a negative clamper. So what is positive clamper is when a negative peak of the signal is clamped above to zero, then the signal is said to be positively clamped. So positive clamper is also called as negative peak clamper. Okay, if I clamp negative peak, okay, to some level, and if I increase the amplitude, the waveform grows positive side. That's why it's called as positive clamper. So negative peak clamper is called as positive clamper. Because negative peak I am clamping. Clamping means we are fixing to some level. After that, if I try to increase the voltage, the waveform will not go negative side because negative peak is already clamped or fixed to or pinned to some level. So if I try to increase, waveform grows positive above zero. It will above that level it will grow. That's why it's called as positive clamper. Similarly, if I clamp positive peak to some level and if I try to increase the amplitude of your input signal, the waveform, since positive peak is already clamped, only negative portion is going to increase. That's why positive peak clamper is called as negative clamper circuit. Okay, so let us do one by one. First we'll do, okay, first we'll try to uh, do positive clamp without a reference. Okay, first we have to do with and without reference. So the circuit diagram for this one is this. Okay, for positive negative peak I have to clamp, no, so diode should be opposite. Okay, diode should be reverse direction here. Now this is, there is no reference voltage here, there is no reference voltage here. So during the negative off cycle here, okay, during the positive off cycle, the diode is reverse bias, no current actually flows through this and capacitor will not charge. During the negative off cycle, diode is forward bias and diode acts as a short circuit and capacitor is going to charge with polarity plus here, here, plus here, minus here, plus, minus. And again, once again, positive off cycle will come. In that time, diode again is forward, this becomes reverse bias, open circuit, but already capacitor is charged to with plus and minus here with peak value. And here also you will get this. So you are going to get input voltage is added with this capacitor voltage so that output whatever input is there now that will come above this level. Okay. But in the when the again in the negative off cycle, okay, the diode is forward bias acts as a short circuit. Here short circuit means it acts as a voltage source of 0.6. So that much voltage it will come here, negative peak. Okay, always this will be at negative peak will be clamped to without reference voltage. If the diode is ideal, it is clamped to 0. Otherwise, it will be clamped to minus zero point 0.6. And if I try to increase the voltage, and this will be clamped, that means it is fixed here. The waveform will grow positive side. That's why it's called as positive clamper. Positive clamper is also called as negative peak clamped to some level, and waveform grows in positive. So let us simulate this. We need one function generator, we need capacitor, diode and resistor. So I'm opening this. So already circuit is there. Once again I'm going to rig up the circuit. Same circuit I'm going to rig up: function generator, oscilloscope, capacitor, diode, and reference voltage on resistor. Okay, let me do this file. Go to file, new, select blank one, a little bit zoom it. Okay, so now let us do this. First, go to place component, select I want one DC source. First, without reference voltage, no. So let me don't take this one. Let me take only diode, capacitor. So it is there in the basic. The basic. Let me take capacitor. Is capacitor. Next, you take one diode. You have to place. Press escape if you don't want. If you want to place, rotate, control R. I am doing positive, negative peak clamper. That's why without reference voltage I'm not adding. Then input function generator. Press escape if you select the wrong item. Then oscilloscope and ground also. So now let me do the connection. Connect to, don't connect to negative, connect to common. Is across. Let me check the diagram. We connected diode and I need one more resistor here. Place, or you can click here also. Place component, basic in basic resistor. Select 10K. Even if you place some other resistance, double click and change the value to desired value. By default, I think 1K will come, and rotate it by pressing Ctrl R button. Okay, now this is negative peak clamper, also called as positive clamper. I'll rename it. I will place on text box to indicate it is positive clamper. Positive clamper. Why means if I increase the amplitude of your input signal, the waveforms goes positive direction above the, and it is also called as negative peak clamper, because negative peak is clamped, so waveform should grow positive only. Yeah, since negative peak is clamped, if I increase the amplitude, output goes in positive side. That's right. Now let us verify now. So this is amplitude how much I am giving. Double click on the function generator. Let me give 5 volts. We can try output for all the sinusoidal, then triangular and square waveform. Normally, we show the output square wave only for clampers. We can show it for any type of waveform. Let me explain with those sinusoidal only. Later, we can change it to square wave last. Okay. So this 1 hertz, you change it to 1000 hertz so that we can stop at single plot. Okay. Now run button is not enabled. Please see here. That means any other circuit is running. Yeah, clipping is actually still running. This one circuit is okay. Now, okay. Now, okay, now I am going to run this program. Click run button here. Output should be DC. Please remember, output should be DC. You are getting very close waveforms now. So there is a time base. You can observe here. The oscilloscope. You can increase the time. That's per division. 10 millisecond is there, no? 10 millisecond per division. That you change it to 5 millisecond per division. Okay, 2 millisecond per division, 1 millisecond per division. So that is x-axis. X-axis 1 division is equal to, okay, 1 millisecond now. And observe here, the negative peak is clipped here only. It is clamped to here only, 0. Because the diode I told, the negative of cycle only diode is forward bias and acts as a voltage drop of zero point 0.6. So minus zero point 0.6 is coming here. Now if I try to increase the amplitude, waveform grows positively. So let me check whether it is possible or not. I will try to check whether if I increase the amplitude, the waveform negative peak is clamped here only. Okay, waveform will grow upwards. Now whether it's continuous, I don't know. I will check it out. See, I'm increasing. I'm increasing. Negative peak is clamped there only. Waveform is going upwards. Understood? Negative peak is clamped here only, and the waveform is going upwards. That's why it's called as positive clamper. And it is negative peak is clamped to this level. So this is without reference, because without reference it acts as voltage of minus 0.6. Positive is this side, negative is this side. So minus zero point 0.6. So this voltage is below, okay, below, here you can see zero point 0.6 small voltage is there. Now I can change the signal to triangular wave. You can change the signal to square wave. I want to see both input as well as output. I want to see both input as well as output. Okay, to see both input as well as output. So now one more channel is free in the oscilloscope. One more channel is free in the oscilloscope. So in this I will see input. Stop the program. Go left side. If you are getting like this, just click escape button. It will go. Or come down. Connect to input side. Okay, and ground common to both. See, for channel A negative, channel B negative, all are connected to the common ground here. Now I can see input as well as output. If I increase the input, Okay, channel A is connected to the input side. Output is actually not in the channel B. Output is not clamped. Only positive. Channel A is actually clamped to here. Okay, I showed no. If I increase this amplitude, I have to run this. After that, you can observe. So now channel A, channel B. Which one is channel B? Channel B is this. So let me change the color. Use this positive of channel B. Right click, segment color, change it to any color you want. I am changing to blue color. Output I am changing to another color, green color. Any color you can change, pink color or any color. Okay, now run this. Output is pink color. Output is pink color. You can change the color also. In the output, negative peak is clamped here. Input is a no clamping. Now if I increase the amplitude, input is increasing both positive negative side. But output pink color, it is negative peak is clamped there only. And the waveform, if I increase this, it is growing upwards. Okay, that's why it's called as positive clamper. Okay, so now with reference, how to do? For with reference, see it is always zero point 0.6. Now additional voltage you have to add here. Additional voltage you have to add here. So if I want to clamp negative peak to minus 2 volts, I want to clamp my negative peak to minus 2 volts. What you have to do is you have to add additional minus 1.4 you have to add here. So for that what you have to do is, please see here, you have to stop the simulation, select this red color wire, delete it, go to place component, go to go to power groups, go to sources, select DC power, click OK. Then if I click this negative peak will go to the positive side direction. Okay, it will go to plus. If I connect this to 1.6, okay, plus 1.6 minus zero point 0.6. So plus 1 volt will come in the negative peak will be clamped to 1 volt, plus 1 volt. If I reverse this, control R, and change this one to minus 1.4, change that value to 1.4, value I change it to 1.4, double click and change. Now it is minus zero point 0.6 minus 1.4, total voltage is minus 2. Output is clamped to minus 2 volts now. You can check now. I am going to run this. You can see now I will change the scale to 2 now. You can see increase the time base. Click single. Please observe output is pink color. Okay, output is pink color. It is one division. One division multiplied by channel A. Pink color channel A. Channel A 2. 1 into 2 is 2 volts. Negative peak is clamped to minus 2 volts. If I want to clamp this negative peak to plus 1 volt, if I want to clamp this one to plus 1 volts, then you have to reverse this battery supply, give 1.6. So that plus 1.6 minus 1.6, it becomes plus 1. So this will shift it to 1 here. It will go above here. If I give negative voltage, it will come down. If you give positive voltage, it will go down. So negative is diode direction is opposite here, upwards. So it is negative peak clipper, and if they increase the amplitude, positive side the waveform is going to come. So now if I increase the voltage, if I increase the voltage, it's actually increasing. Negative peak is clamped here only. If I decrease, we'll stop and run. So this is about positive clamper. Thank you.